Okay, welcome back to Cool Clubs Podcasts. We are lucky enough today to have Scott Taylor from Taylormade. You are the product development, research and development for the irons in Taylormade, am I correct?
Correct.
Excellent. And as always, we've got our legend, Mark Timms here, CEO and founder of Cool Clubs. And today we've got something that I know that everyone's going to want to talk about.
Yeah, this is, just give it a preface. I mean, this has been our number one selling iron on and off for the last, 5 years or so. So we're real excited about this one, obviously, and you got a new version of it. I'll premise it, we did do some initial robot testing stuff, and typically we don't see a big jump in technology, especially something that's one of the best in the industry already. But we found you got 4 more yards and a little higher launch, a little less spin, but with the same stopping power. So you actually gain, that's a fair amount of improvement, when you see irons from year to year to year. So fill us in on what you did.
Yeah, thanks, Mark. There's more engineering that went into this product than any product we've ever developed in the past. So I'm happy to see that you guys are seeing the same performance that we're seeing back at headquarters with regards to player testing and robot testing. This iron's all about what's inside, right? I mean, P790 historically has been a beautiful looking aesthetic iron. I think we've continued that. But if you look at internally, I think all the performance is under the hood of a P790.
Well, it's one of those things, like we've done our own review on this independently, and our first thing that we talk about is like, this is the 3rd iteration, so you've done this before, right? But how do you change something that's been like a real iconic feature in the golf industry for so long? Like, where do you even start to say, well, what can we change about something that's just dominated in this iron space? Where did you start?
Right. Well, actually it's the 4th iteration.
Oh, so, 4th? Okay.
But you're right. Yeah, it's hard to improve, on every one. And so what you'll notice, like, I don't know if you guys have a head that's sectioned or anything. If not, what?
No, but I've seen the cut opens on it. Yeah, so I mean, you obviously each iron you've done individually, right? I mean, each one's different with a CG placement and everything.
Right.
Yep.
Exactly that, right? So first of all, it starts with the tungsten placement, right? And so historically, tungsten's been a single design, fits the entire set. Now each iron has its own individual design tungsten, and the center of gravity for every iron is designed specifically for that SKU. So we'll start with the 7 iron, for example, right? 7 iron has enough loft, guys can generally get it in the air. So what we did, right, we took that tungsten, we kind of elongated it vertically, pushed it more towards the toe to increase the MOI. So what the golfers can still consistency on an offset or impacts, more shots captured, larger COR area, but we still lowered the CG as well, so you can see a little bit higher launch, and with that consistency, you're going to see more distance.
We saw basically almost over a degree actually in launch, which is substantial, and a couple of RPMs lower in spin. But so you got more distance, which is great. Everybody wants more distance, but you didn't give up any stopping power because of that increased launch angle, which is great.
Exactly, that peak height, right, is going to counteract whatever reduction of spin you're going to have.
I've always been a fan of that. I'd rather, I hit the balls super high and don't spin it much, but I'd rather hit it high and land it and not worry about spin than, hit it low and spin it a bunch. And obviously you use a lot of energy having the ball climb, so it's not optimal.
Exactly, Mark. But it doesn't top of the 7 iron, right? So every single iron's different. So if you go to the long irons, the 4 and 5 iron, those irons historically are harder for that type of golfer to get the ball in the air. There's just not as much loft as there is on a 7 iron or 8 iron. So what we've done for that tungsten design is very shallow, it's very low. So we've lowered the center of gravity on those irons. So you're going to see your consumers have even higher launch of a 4 iron and a 5 iron. So every single iron internally, if you look at it, we're using what's called topology optimization, kind of like AI, right? Where we tell the computer, this is our design space, okay? All the internals. We want our CG to be here. We want our launch to be here. And we want our sound and feel to be a certain place too. That's about harvesting mass up high, but you can't just grab a bunch of mass and put it low, because what that does is it lowers the frequency of the iron, so you get that real clacky sound, which consumers don't want. So what we do is we go back in and we use ribs in order to stiffen certain regions. So what a rib does is it'll stiffen a region, but not utilize a lot of mass. So we keep that CG low, but the sound and feel at a real optimal kind of frequency and duration.
Have you still kept, the story of the original P790 was, speed foam, foam filled, that's going to quieten it down, soften the feel, create that whole experience. So now you're bringing in some other material properties to help with that.
Exactly that, right? So when it comes to sound and feel, there's a few aspects there, right? So there's the frequency, which I talked about, which ribbing, right, raises the frequency of an iron, right? So think about it like this. Think about if you had a real long, thin steel, right, plate, and you kind of wobble it, right? It's that real low frequency, doesn't sound good, right? So that what happens to an internal structure of an iron as you thin it out, it gets that real low frequency, okay? So we'll go back and we put ribs in there. We use topology optimization to tell us where to put these ribs to raise that frequency, okay? Now we've raised the frequency, but then there's the duration. So now you want to dampen out the length of the duration. That's what speed foam does.
Okay.
So it's still flexible. It doesn't limit the amount of flexibility on the face, which is hence the term speed. Taylormade, we have to put speed in front of everything. So we're not limiting speed, right? But the foam is dampening the sound and feel.
Yeah, when you add, you take a sheet of steel, right? If you think about it, right, and just drop it on the floor, go ding. If you mount a piece of rubber onto it and drop that same thing, it goes thud, which is kind of what we're looking for, right? And 90% of feel is sound, right? So I mean, it's really what you hear is what you feel. So that sounds really important. We actually thought about, and we still might do this. We talked to Dr. Mace about it. Actually measuring the frequency of the different irons as we hit them, to kind of and recording them so that people get some idea of sound and feel.
Yeah, that's what we do, right? So I mean, obviously, we're using finite element analysis in order to design an iron to where we think it's going to be. But then after we prototype the iron, we do lots of recordings at different levels and in a different location, right? You want to record sound and feel when you're the person swinging the club, but then also, hey, your buddies that are standing on the tee, a little bit back right of you, we record sound and feel there because that matters as well.
Yeah, and in a bay and outside are completely different experiences. Sometimes you want to keep that as consistent as possible. Yep.
Exactly. Indoors is a challenge because you have echoes and that kind of stuff.
Right.
As I'm sure you guys know. But we do a lot of our recordings both internally and externally. We use both robots, better golfers, what we call success players, which are generally a little bit higher handicap players as well.
So let's just go back to the aesthetics, if that's okay. Like, it's one of those things, right? 790, so iconic. You don't want to reinvent the wheel and change it entirely, but you want to use the information you've gathered over the past few years to push forward and make some changes that are going to help the player. When you look at it, I think you've made some positive changes. It's a little more subtle. It's a little more towards that blade look and real simplistic. But is there anything in there that's ergonomic? Is the sole changed, or the heel to toe length? I mean, I know that was always part of that 790 measure was the heel to toe length, right?
Yeah. So a few things there. Like, first of all, I mean, golf is such an aspirational sport, right, guys? Like, no one wants to show up to the first tee, carrying a bunch of shovels, right? So it's really important for us to get this aesthetics looking amazing, right? The guy wants, which is what I think P790 does, is all the performance is under the hood, but it's an amazing looking iron, first of all. So you're right, very subtle tweak, very monochromatic appearance. And then with regards to shaping, very similar to what we had on the previous generation, some small heel relief on the short irons.
And then, so...
Sorry, go ahead.
Oh, no, go on. I was basically going to allude to your Stealth HD program. That's a very, very extreme version of your CG that you were discussing there in the 4-iron, but obviously that's an external view of it, right? That thing looks like a technology program, and it hopefully delivers to a certain end. You've basically, it sounds to me as though you've managed to put that into a 790 package to some extent.
Right, exactly. I mean, we have tungsten working for us, which we don't have on the Stealth HD, right? So something like a Stealth HD, which is one-piece cast, you have to do that through geometry. That's why you have a very wide sole in order to get that center of gravity low. With the P790, we have tungsten, much higher density, right? So density of steel is about 7.8 grams per cc, where tungsten, we're using 15 or 16 grams per cc tungsten. So a lot more mass concentrated, so we can still have very shallow or small soles and still get that center of gravity very low.
Awesome. It's a great looking iron, and we did touch on the numbers right at the beginning there. So we do some really standardized testing in terms of we try and keep it the same across the board, or we do keep it the same. It's an 80 miles an hour test, 2 degrees angle of attack down, 0 path, 0 face, and we keep the shaft the same, swing weight, length, manufacturer's loft, and that's something that you did keep the same between last year's model and this year's model. So there was no cheating of distance. But like Mark said, we saw essentially a full degree higher launch and about 300-400 RPMs drop in spin. Is that purely where the distance has come from, or did you manage to squeeze any ball speed out of this thing?
I didn't even look at ball speed.
I didn't look at ball speed either.
We missed that one.
Yeah, there should be a little bit more ball speed in there as well. We have a new face design, right? That's optimized to give you a little bit more COR at balance point, as well as more COR on off-center hits. And then I think you're going to see more ball speed with more shots you hit, just because of the consistency of the higher MOI. Right? I think we're around 10% higher MOI than we were in the years previous.
Wow, that's substantial though. That's a good amount.
Yeah, so you get more ball speed. That way you get more spin consistency, and you get some launch as well, like you guys saw.
Yeah.
I'd also be curious to see if you guys saw anything with deviation. It's something that we work really hard on, is more consistency or more straighter irons. So what occurs when you develop a high COR iron is because of the asymmetric face shape. Okay, so as you go thinner face on an iron, an iron is asymmetric, taller in the toe, shorter in the heel. What that wants to cause is a right deviation for a right-handed golfer. Okay, so as you make a high COR iron, the ball wants to slice, which is generally what we don't want to design into a product like this. So we actually have some patents around stiffing different regions of the face that actually make that asymmetry. So it's more constant stiffness across the face. So if you look at other competitors on their high COR irons, especially long irons, you can see right tendency, and we should be a little bit straighter, just a few yards left of center.
Interesting. We definitely did see it going a little further left on the half-inch graph. Anyway, so when just going into more technical here than anything else and generic, but because there's a greater distance between the heel and the toe, that weakens the material, like makes that area softer essentially, and then because this is a shorter distance, it's more rigid in the heel.
Think about it like it's basically beam bending, or think of it like a trampoline, right? The longer distance or span you have, the more flexible that region is going to be, right?
Yes.
So your heel, like think about it as a bridge, it's a really short bridge. The toe side, it's a little bit longer bridge. So if you had constant thickness, right, the same thickness, those two different spans, the toe is going to bend a lot more, okay? So it's going to cause that right tendency.
Yeah.
So what we do is we go behind the scenes and thicken the toe region, still keeping at the COR limit, but basically you're keeping the amount the face bends symmetric across everywhere on the face.
It's so funny. I've never heard that in all the time. I love getting into the tech of it, and I've never heard anyone. But it makes total sense, obviously. Like, this is the stuff that you guys do day in and day out, and people look at a golf club and they just do not know that exists.
Yeah.
Right. I mean, it's a problem that we created. You go back years ago, we didn't realize there was a problem, so they started doing high COR faces, right? High COR irons. Those didn't exist 15 years ago, right? We started developing Burner 09 and Burner 2.0.
Right.
It was like, wait a minute, these balls are going more right. So that's what I love about engineering, right? You go and you solve a problem, and usually you develop some technology around whatever that solution is.
Or you create a new problem by solving the other one.
It's keeping me and my team employed.
That's right. Well, you're doing a great job. This 790 line, it's going to be one of the hottest things on the market this year. It'll definitely get you through to the next season for sure. I'm excited to hear how you go from here. Where do you go?
Yeah, I mean, it's definitely the most engineered iron set that we've ever developed. The time, the energy, and every single SKU of the entire set, pretty immense. We'll have to get you guys some amazing pictures to see the internals of every single SKU. Looks different. And this, it's our very first P790 that has what we call flighted CG, right? So it has the lowest center of gravity in the long irons and the highest center of gravity in the short irons, right? So why do you want that? The long irons, your 4-iron, your 5-iron, harder to get in the air, so you want that CG lower to help that golfer get the ball in the air. The short irons, there's enough loft to get the ball in the air. You want higher CG to increase spin for more stopping power. So every single SKU has a nice linear progression going from the long irons to the short irons.
It makes sense. We're excited. We appreciate it as club fitters having this kind of technology. It makes us look better than we are, for sure. And we look forward to everything TaylorMade does, because it's always exciting.
I'll see you guys next week. Actually, I'll be out there Tuesday.
Oh, great! We'll stop by. I'd love to say hi.
Yeah, I might do that. Let's see if I can find you.
Thank you so much for your time today, Scott. We really appreciate it, mate.
All right. See you.
Of course, guys. Thanks. Take care.
Bye.
See ya.
Thank you.